Hello, Crazy Math Nerds. This is part 2 of talking about area under a curve and finding it when you don't know exactly what shape it is and you just maybe are given points about a problem. So this is number 2 from page 138 of Master Math Mentor. And let's read the problem, get into it. Here we go. We're jumping out of a plane. Woo! And your acceleration decreases as you fall because of air resistance. So this is acceleration. And they're asking you about velocity because what do we know? Acceleration times time equals a velocity. And right, because in acceleration it's the change in velocity, right, over time. And so if you multiply them together, you just get velocity. So we're going to do the same approach as we did the last one, where we're going to look at the left-hand rule and then the right-hand approximation and then talk about those. So I've actually already done this for you. I'm just going to point out to you where I got some things. So for the left-hand approximation, the velocity is approximately 1 times, and we're going to use the, so like this is your first rectangle right here, right there. That's your left, and that's your right. So we're going to use the left-hand value, the left-hand y, which is 9.81. And there's a little 1 right there. It's kind of hard to see. For the next rectangle, that's going to be from there to there. You're going to use the left-hand value. There it is. And then you're going to keep doing that until you get to your last rectangle. And that's rectangle 5. And I know you think I'm crazy by writing 1 times for all of these, but at some point your distance for each interval will not be 1. And so I'm just making an emphasis on that. And they don't always have to be evenly spaced out either. So make sure that you're always putting in your height, your width of your rectangle and using the values appropriately as the height, okay? When you add all those up, you get 37.77 meters per second because this is velocity, okay? So let's look at the right-hand approximation. So for the right-hand approximation, same concept as far as how I'm looking at this. Here's the rectangle, like if I drew it, and this is left and this is right. So I'm going to use this right height as my first height and continue that process all the way through. And I get 40.399. Oh, I didn't label, so bad, meters per second. So we know that the true velocity after 5 seconds lies somewhere in between the 37.77 and the 40.399. Okay? All right. So let's look at a different kind of Riemann sum. And let's see if I can get rid of that. There we go. And figure out how to do it. So a Riemann sum, I'm going to say this again, a Riemann sum is finding areas using rectangles. Rectangles. Okay? And we've already talked about 2 kinds where you use the height on the left or the height on the right. Well, this is an old AP problem from a long time ago, and we're going to read this and see what they ask us to do. So the rate at which water flows out of a pipe in gallons per hour, so water flowing out of a pipe, gallons per hour, is given by R of T. See, here it is. Here's all the values. The table to the right shows the rate is measured every 3 hours for a 24-hour period. We're only going to do part A because that's all we're going to be responsible for today. So it says use a midpoint Riemann sum with 4 subdivisions of equal length to approximate this. And then it says, and we know this means finding that area, right? From 0 to 24 under this curve. Use correct units. Explain the meaning of your answer in terms of water flow. So it says 0 to 24, and it wants 4 subdivisions, so that means I'm going to need something every 6 hours, okay? All right, so I know that I'm going to go from 0 to 6, right? That's the width of my rectangle. But in a midpoint, to find the height, you go in the middle of those 2 values, and you find the y value that goes with that. And that is going to be the height of your rectangle. The next interval will be from 6 to 12. So that's a length of 6, width of 6, excuse me. And the height is not going to go with 6 or 12. That would be a left or right hand. We're going to go in the middle and get that middle guy's value. And then we're going to go from 12 to 18. Now, are y'all thinking, this is really easy? I know, it isn't bad, is it? So this is a width of 6. We're going to go in the middle and go get the y value that goes with that. Then we're going to go from 18 to 24. And we're going to talk about the y value that goes with the middle guy, right? Width of 6. We're going to use the height of 10.2. And when we get this, we get 258.6, but we got to think about what that means. So what happens when you integrate a rate? When you integrate a rate, you're going to get the amount present. Just like integrating the rate, because isn't velocity the change in distance over time? Isn't that velocity? Right? And so what happens when you integrate this? You get the distance, you get the s, right? Okay, so that's what we're doing. When you integrate a rate, you get the amount of whatever it is your rate is. And so this is going to be in gallons. So if I had to tell you what this means, I would say 258.6 gallons is the approximate number of gallons that flowed through the pipe in a 24-hour period, right? So that's the statement they want there. So that's midpoint. Midpoint is when you have to use the middle values y as your height. The middle values y as your height. All right, so that's midpoint. In the next video, we will talk about the trapezoidal rule, so come back for more fun.